Hi everyone. This video is going to be a review of our linear relationships unit. So really the idea is to go through and kind of remind ourselves of some of the work we did in this unit and really give you an idea for the types of problems that you'll see from this unit on the final exam. So the first part of this, we talked about the coordinate plane. And so what I have here are a couple example questions. So the first one is, which point is located in quadrant 3? So obviously for this, you'll need to remember what those quadrants are. So for a quick review, if we start in the top right, we have quadrant 1, or we could just use the number 1. And we move counterclockwise. So here we have quadrant 2, quadrant 3, and then quadrant 4. So since I'm looking for quadrant 3, I can look here. Now remember, we don't include points that are on the axes. So the only point that's actually in quadrant 3 is going to be point D. So I'm going to circle option D. Now the second question are asking for the coordinates of point E. So remember, the coordinates, when we're talking about coordinates, right, we're talking about the same thing as an ordered pair. And we know an ordered pair looks like x, comma, y. So x tells us to go left or right, and y tells us up or down. So if I'm looking for point E, we know that when we're plotting points, we start at the origin. So the first thing I have to decide is how far left or right to move. But since E is on the y-axis, I actually don't move left or right. So I know my x-coordinate is 0. Then I have to go down 3, so my y-coordinate is -3. So if I look in my choices, then I can find my answer here is C, 0, -3. So those are the kinds of questions you might be asked about the coordinate plane. There's also some other questions included in the multiple choice practice at the end of these notes. So the next thing you might see in this part of the final is talking about linear relationships. And the important thing to remember here is that a relationship is linear if the rate of change is constant. And of course, by constant, we mean it's the same. So, for some example questions here, it says determine whether or not the relationship below represents a linear relationship. So what we're really going to focus on here is the change in y. Because I notice that x is always changing by 1, so I really need to focus on the change in y. So here, to get from -2 to 3, now sometimes students have trouble with the negative numbers. If it helps you, maybe draw a quick number line. So if I start at -2, I go up to -1, 0, 1, 2, and 3. So I'm trying to get from -2 to 3. Well, to do that, I'm going to the right 1, 2, 3, 4, and 5. So that represents a +5 for my rate of change. Now, from 3 to 7, that's only adding 4. Since those two numbers are not the same, my rate of change is not constant, so I'm not linear. For number 4, same question, determine whether or not the relationship represents a linear relationship. I'm still looking at the change in my y values because I notice x is just changing by 1 every time. Now, since I go from 5 to 3, this actually is a negative rate of change, which is okay. Linear relationships can have a negative rate of change. So to get from 5 to 3, I subtract 2. From 3 to 1, I also subtract 2. Since those two numbers are the same, here we have a linear relationship. Okay, so now I'm going to flip. We're going to talk a little bit about slope. Remember, there's 4 different cases or possibilities for slope. So if my line goes uphill, I know that's a positive slope. Think of Ski Dude and his puff puff positive. If my line goes downhill, I'm skiing downhill, that was negative. So that was our nice negative. Now, if I have a horizontal line, remember we're skiing along that flat ground, he said that was 0 fun. Our slope here is 0. And the last one was when slope due went over the cliff, and he said that was undefined. He actually said it much more dramatically. But we know that slope is undefined. So we need to be able to recognize when we have those types of slope. Now, we also know we can define slope in the following way. So slope, we know we use the letter M. And we said we could define it as rise over run. And that's what we're going to look at in the next problem. So my next example question asks me to use rise over run to find the slope of the line. Now, before I actually start looking at the choices, let's take a look at the bottom here. I made a note of some test-taking strategies. So first, we're going to look at the line and decide if it's going uphill, which would mean a positive slope, or is it going downhill, which would mean a negative slope. Sorry, can't quite fit that in. Okay, so we're going to decide if it's going uphill or downhill and eliminate any graphs that don't match. So if I look at my line, if I start at the top here and go down, clearly we're going downhill. So I know this is going to be a negative slope. So I'm going to kind of help myself out here and eliminate any choices that aren't negative. So it can't be A and it can't be C. So now I can use rise over run to find the correct slope. So I've kind of narrowed down my choices. So now to find the slope, the first thing I need are some nice points on this graph. So to me it looks like I see one here. That looks like a nice point. And then maybe the next one is down here. So to get from this point to this point, I have to go down. So my rise is going to be a negative 1, 2, 3. My run is going to be a positive 1, 2. So I have a slope of negative 3 over 2. Choice B. Okay. Next topic is our slope-intercept form, which hopefully we can all say in our sleep by now. Slope-intercept form we know is y equals mx plus b. M represents the slope of our line, and b represents the y-intercept. So to graph an equation in slope-intercept form, we're going to first plot the y-intercept. Then, starting at the y-intercept, we're going to use rise over run to locate a second point, and then we're going to connect those points with a straight line. Now, obviously, we would do this if we didn't have a multiple choice test. I'll show you an example of a multiple choice question in just a minute here. But just for practice, let's do this. So, for example, if I had this equation, y equals negative 2/3 x plus 4. I know my m is the number in front of x, the coefficient of x, so that m is negative 2 over 3. Notice that I don't include the x with my slope. My slope is just a number. My b is this value here, the constant, so that's a positive 4. And if we could write that as an ordered pair as 0, 4. So now I'm going to follow the steps we wrote up here. My first job is to plot the y-intercept, which is my b value. So I'm going to plot the point 0, 4. Again, that y-intercept has to be on the y-axis. And then I'm going to use my slope to find my next point. So this tells me my rise over run. Since my rise is negative, I go down 2, and then run to the right 3. So now I have 2 points, so I'm just going to go ahead and connect up with my straight edge. And there's my line. Now, you guys are taking a multiple choice final, so you won't actually be graphing the line. Here's what your question will look like. They're going to give you some graphs, and the question will ask which of the following is the correct graph to that equation. Now again, I'm going to show you a strategy that will actually make this easier on you. The first thing we're going to do is find the correct y-intercept and eliminate any graphs that don't match. Well, I know from slope-intercept form that this plus 4 is going to be my b value. So that means the point 0.04 has to be on my graph. So if I look at this one, its y-intercept is 4, so I can't cross that out. In choice B, the y-intercept is down here at -4, which doesn't match, so I know that can't be my graph. Choice C, again, it looks like 0.4 is on the graph, so that's still a possibility. But at least I've eliminated one choice. The next thing I'm going to do is determine the sign of the slope. So really, I'm going to decide, should my line be going uphill or downhill? And I'm going to find the graph that matches. So in this case, my slope here is a -3. That means my line better be going downhill. If I look at choice A, that line's clearly going uphill, so that can't be it, which only leaves me choice C. So that may be a good way to kind of work through those answers if you're not sure which is the correct graph. All right, next, we're just going to review really quick how we rewrite an equation in slope-intercept form. So for example, I might have an equation that looks like this, where x and y are on the same side of the equation. We call that standard form. And we need to get it into slope-intercept form. Again, we need to get y by itself. It needs to look like y equals mx plus b. So here we're going to use those solving skills. 3x plus 7y equals -21. If my goal is to get y by itself, the first thing I need to do is move away this 3x. So I'm going to do that by subtracting 3x on both sides. Once I do that, I have 7y left here. Now, the important thing to remember is that I cannot combine these two terms because one has an x and one doesn't. So I'm going to grab my x term with its coefficient, so -3x, and then I'm going to write the constant next door. Again, keeping its sign as well. Since it was negative here, there's a minus here. Now I just have to do one thing really. I have to divide by 7 to get y by itself. And if I simplify, -3/7 I can't reduce, so that's just going to stay there. -21/7, I can use my calculator, and that's a -3. So now I'm just going to find my choice, -3/7x minus 3. All right, and last but not least, we have horizontal and vertical lines. So first of all, we just need to remember horizontal lines look like this. Okay, it's a little wobbly. I apologize for that. Okay, horizontal lines. And remember, their equation looks like y equals a number. So in this case, since we crossed the y-axis at 2, my equation is y equals 2. Vertical lines look like this. And their equation is x equals. In this case, we cross it x equals -3. And remember, we have our silly kind of little shortcut. Horizontal is HOY. So we remember that horizontal lines have equations that look like y equals. Vertical lines are VUX. So vertical lines look like x equals. So a question of this on the final might look like this. Which of the following is the correct graph of y equals -4? Now there's a few ways we could do this. The first way would be to say, well, I know if it's y equals, it has to be HOY, right? So I know I have a horizontal line that crosses at -4, which makes choice B. If you like doing the 3 points method, you could also do this. We could write 3 ordered pairs. Our rule says that y always has to be -4, so I'm going to fill that in for the y coordinate. And x can be anything I want. It could be 3, it could be 0, it could be -2. If I plot those points, 3, -4, 0, -4, and -2, -4, I notice that, again, it's choice B. That's the line that goes through all three of those points. Okay, so that is a quick recap of our unit on linear relationships. I would recommend trying the multiple choice that follows this review, seeing if you can do that without your notes, and then the answers are included in the packet to check. Good luck!